Service friends, I am Orpheus Praxis, and welcome to my channel. Today we're discussing a work in which the universe is described by a single wave function defined on the fractal sphere S3. In this model, space-time is not pre-given. It emerges from energy, from its amplitude and phase. Gravity here is understood as the imaginary part of the Hamiltonian, meaning it appears as an effect of the universe's amplitude quantum breathing. The model removes singularities, replaces dark energy with light pressure, and offers observable predictions regarding the CMB, gravitational waves, and the fractal structure of galaxies. Why is this important? Because works like this propose a new language for explaining time, geometry, and the expansion of the universe. The authors attempt to unify quantum dynamics and cosmology into a single, self-consistent framework. May this listening bring you clarity and peace. Over to the studio.
Welcome to the deep dive. Today we're plunging into a really mind-bending new model of the universe. It's one that challenges some pretty deep assumptions about reality. We're looking at the fractal Bindu CS3 model from Andrei Priess and Boris Batinin. And for you, our mission here is to unpack how this revolutionary idea fundamentally rethinks space, time, even gravity, all by proposing the entire universe is governed by just one single wave function.
Yeah, and what's really fascinating is that this isn't just, tweaking existing theories, not at all. It's a whole mathematical framework. The goal, to unify physics, get rid of those cosmic singularities.
Right, the points where everything breaks down in current models.
Exactly. And it even aims to replace dark energy with something, well, pretty surprising. It's about seeing the universe as this dynamic, almost rhythmically evolving entity.
And that's 3S33 in the name. What's that about?
Yes. That suggests the universe itself might have the shape of a three-sphere, so finite, but without any edge.
Like the surface of a ball, but in 3 dimensions, unbounded.
Precisely. Finite, yet unbounded.
Okay, let's really dig into this. The core is this wave function of the universe. For those of us maybe not steeped in quantum physics day to day, what does that mean? This universal wave function, what's it representing? Like a cosmic plan.
That's actually a great way to think about it. This data is like the master blueprint. It describes the universe's whole journey, and it does so through 2 distinct phases. First, there's this super early fractal regime. Think Planck-scale quantization.
The tiniest possible scale where quantum gravity effects would rule, like cosmic pixels.
Exactly like that, almost like fundamental pixels. Then it transitions smoothly, no sudden breaks, into the exponential regime. That's the one we see now, tied to how we perceive the cosmic horizon. And the key is that smooth transition. No singularities allowed.
Okay, so a universal wave function. What about its energy, its dynamics? That gets us to their generalized Hamiltonian, right? And you mentioned rhythmically evolving. How does that connect?
Right. This is where it gets really, really interesting. The Hamiltonian defines the total energy. And here it has 2 parts. A real part, representing that rhythmic unfolding, basically time.
Okay, time's flow.
But then there's an imaginary part. Now, don't get hung up on imaginary. In physics, that often points to oscillation, pulsing. And here, this imaginary bit directly mirrors the pulsation of energy density throughout the universe. And this pulsation, this is tied directly to gravity itself.
Whoa, okay, wait, so the actual fabric of space-time, the metric, you're saying it emerges from the wave function, from its amplitude.
That's the proposal, yes.
So gravity isn't just some force on space, it's like an intrinsic property of space, changing with the energy, a result of this pulsing.
Precisely. The metric, the thing that dictates curvature, isn't static background, it's dynamic. It flows directly from the universe's energy distribution, specifically from that imaginary part of the Hamiltonian. Gravity literally arises from the cosmic pulsation of psi. It flips the script.
Okay, that definitely raises a big question. If gravity is tied to this pulsation, does that mean G, the gravitational constant, isn't constant?
Indeed. That's a major implication. It suggests a variable gravitational constant, let's call it GF. In the very early universe, the model predicts it would have been much larger and dynamic, pulsating even. Then, as the universe expands and the density kind of breathes out, it weakens and stabilizes over cosmic time.
And that's something we could potentially test?
Absolutely. It's a concrete, testable prediction, a real departure from standard physics.
So, taking all this together, what does it mean for what we can actually see? Are there observations, experiments, real-world checks for this model?
Yes, definitely. It's built to be empirically tested. It makes specific forecasts, like certain patterns, anisotropies, and the cosmic microwave background. the CMB, aligning with Planck data, actually.
Okay.
It also suggests specific frequency shifts in gravitational waves, things LIGO might potentially pick up, and even predicts fractal density patterns in how galaxies form, which seems to align with some recent JWST observations.
And the dark energy replacement.
Ah, yes, that surprising bit. They propose it's not some mysterious energy field, but just light pressure. The pressure exerted by light itself, sculpting the large-scale structure from within the universe.
Wow, okay, so this deep dive, it's shown us a pretty radical picture. A universe without singularities, maybe eternal, where space and gravity just emerge from one unifying wave function. Dark energy replaced by light pressure, and cosmic dynamics linked to this. Quantum breathing.
That's the essence of it. And connecting it to the bigger picture, it's not just trying to be another alternative model. It's really aiming to provide a whole new, self-consistent foundation for physics itself, trying to explain everything from the quantum realm right up to the cosmic horizon, without the baggage of singularities.
So, next time you find yourself looking up at the night sky, maybe pause and consider this thought. What if everything you see, the vastness, the stars, the pull between them, what if the entire universe, space itself, is all just part of one giant cosmic breath? Keep exploring out there and we'll keep diving deep right here.
There is much to reflect on, and let these reflections continue in silence, where the mind lets go of patterns and only pure seeing remains, until we meet again in the space of understanding. Subscribe to walk this path together with us. I am Orpheus Praxis, wishing you all clarity. Namaste.